Alright, we're back for part 2 of lesson 7.4, talking about special right triangles. Real quick, we learned about this type of triangle in the previous video for the first part of lesson 7.4, and we also learned about this type of triangle. So what I want you to do real quick is pause the video if you need to. It'll probably take you a minute or so, but I want you to write down the angle measurements and the side lengths that we talked about in the first part for both this triangle and for this triangle. So copy them down into your notes, write down those angle measurements, write down those side lengths, and then we'll get started here in just a second. So I'll give you a few seconds to do that, but pause the video, do that real quick. Alright, you should have that done by now. If you don't, seriously, pause the video, do it. I know some of you don't think I'm serious when I say that, or you just don't want to, but yeah, you need to. Alright, here we go. Two congruent sides. Means I have to have two congruent angles. I've already used up 90 degrees out of my 180, so 90 split evenly is 45 degrees and 45 degrees. The numbers for a 45, 45, 90 triangle are 1, 1, and root 2. Okay, you need to memorize those if you don't have them memorized yet. So 1 goes here, 1 here, and root 2 over here. And remember, I talked about this briefly in the other video, but I usually circle them. We'll see why here shortly. All right, zoom in on that a little bit so you can see it better. Alright, so let's look at the other triangle. Alright, this started off as an equilateral triangle. Equilateral as in 60, 60, and 60 degrees, but we dropped the altitude down to form 90 degrees. So this one here is 60. This one up here ends up being 30. This is a 30, 60, 90 triangle. And the sides were 1, root 3, and 2, and we always say them in that order. 1 goes across from the 30, so we're going to put the 1 down here. Root 3 goes across from 60, so it's going to go over there. And 2 goes on the hypotenuse across from the 90. All right, if you don't remember those things, you need to go back and study lesson 7.4 part 1 a little bit more. Now, before we move on to using these, there's a couple things I have to teach you, and that's what do we do if we get an answer that looks something like this, where we have a square root in the denominator. All right, we don't really like square roots and denominators in math. Now, there is a reason for it. It's actually an older reason. With our new calculators that we have, this usually doesn't actually matter all that much, but we've kind of kept the rule, and the rule has been no roots in the denominators. Let me explain why in the past we didn't have roots in the denominator. Root 2 is 1.414 and a bunch of other decimals. So if I actually wanted to do this division, 1 divided by that, right? This is the way we used to do things. 1 divided by 1.414 and a bunch of other decimals. Now, if you guys remember long division from back in elementary school, when we had a decimal out here, we had to take this decimal point and move it all the way to the end. We have a problem. There is no end to this decimal. And if I did move it, let's say 4, 5, 6 decimal places, just so I could be really accurate, then I have to move this decimal 4, 5, 6 places, the same number. So I would get something like 1 million divided by 1,414,000, whatever. And that is a really, really ugly division problem to do. So what we do in math is we modify this and we make it easier to deal with. So let me show you how we do that. So 1 divided by root 2. What we are going to do is we're going to multiply it on the top and the bottom by root 2. Now, root 2 over root 2, it's the same exact thing. All right, this reduces to 1. All right, if I actually reduce this, it would reduce to 1. If you multiply something, in this case 1 over root 2, by 1, you aren't changing the value of it at all. All we're really doing is changing the way it looks. We did this when we added fractions, when we first started to learn how to add fractions that had different denominators. If we added, 1/2 plus 1/4. Well, we had to change 1/2 to 2/4. And how did we do that? We multiplied the top and bottom by 2. We multiplied 1/2 times 2 over 2. It gave us 2/4. Then we could add it to 1/4 and get 3/4. changing 1/2 to 2/4 does not change its value. All it does is change the way it looks. All right, so that's all we're doing here. We're multiplying by 1. Multiplying by 1 does not change the value, it changes the way it looks. So I get 1 times root 2. Well, that equals root 2. If I take something times 1, I get this thing I started with. Now root 2 times root 2 is root 4. Okay, but we know that the square root of 4 is 2. So now I have this. 1 over root 2 and root 2 over 2 are actually the same exact thing. They just look different. Now, if I had to take root 2 divided by 2, and I had to do that without a calculator, which is how we did things in the past, now that never-ending decimal of 1.414 and a bunch of other decimals is in the numerator. And the 2 is in the denominator, which means I get this, 1.414 and a bunch of other decimals divided by 2. Now, if you look at this division problem and you look at this division problem, this one is a whole lot easier. I don't really even know what these decimals are, but I already start to know the first couple digits of my answer. I know I can bring that decimal up. 2 goes into 1 0 times. 2 goes into 14 7 times with nothing left over. 2 goes into the next 1 0 times. 2 goes into that 14 7 times. And then I'm going to just keep getting more answers there. I don't even want to attempt to do this division problem by hand. This one's easy. So this is why we get the root out of the denominator. Now, I'm not going to test you on why we get the root out of the denominator, but I am going to tell you you have to get the root out of the denominator. So if you give me an answer like this and you don't change it by doing this and change it to this, you're going to get it marked wrong. All right? So you must change it. So let's look at another example here. We have 4 over root 3. Okay, we do not want the root in the denominator. So we multiply the top and bottom by the same thing. In this case, root 3 over root 3, because the root 3 times root 3 will give me root 9, but I know that the square root of 9 is 3. And 4 times root 3, the 4 is outside, there's no root over it, the 3 is inside a root, so we can't multiply 4 and 3 together to get 12, we just write 4 root 3. Now we look to see if we can reduce. If we can reduce, it's going to be this number. They're both outside of the root. We cannot reduce the 3 and the 3. This is under the root. This is not under root. They're not reducible. All right? We could reduce here, but 4 and 3 aren't divisible by the same thing. So that's my answer. Now let's look at one more example. 6 over root 2. So I'm going to multiply by root 2 on the top and the bottom. On the top, I get 6 root 2 over, now root 2 times root 2 is root 4. And the square root of 4 we know is 2. Now here I can reduce. 6 and 2 are both divisible by 2. So I'm going to divide them by 2. 6 is 3. Root 2 doesn't change. We don't divide this right here by the 2. This just stays the same. And 2 divided by 2 is 1. Well, we don't really need the 1, so we can just write this as 3 root 2. Alright? So you need to be able to do that type of thing as we move on into this lesson. Alright, so let's take a look at an example now. We're going to start with our 45, 45, 90 triangle. We're going to do 2 examples of it. So here's our first one. Alright, so 45, 45, 90 triangle. We have a 5 and an x and a y. Now usually, when we've been doing right triangles, you had to know 2 of the sides in order to find the third side by using the Pythagorean theorem. But with a 45, 45, 90 triangle, we don't have to. We can use this idea of a proportion of similarity. Right, now, how do I know this is 45, 45, 90? I have 2 congruent sides. So therefore I must have 2 congruent angles. 180 minus this 90 here is 90. 90 split evenly has 45 degrees each. Alright, now remember 45, 45, 90 triangles have a 1, a 1, and a root 2. So I'm going to put a 1 and a 1 and a root 2. That's why I always circled them before. I talked about that in the previous video. This is why I do it. This tells me that 5 and x and y are the actual lengths of this triangle. 1 and 1 and root 2 are my proportions, my ratios. Okay. Now x is easy. These sides are equal. So we don't really have to show any work on that one. We can just literally write down x equals 5 units. All right. No work required. That's pretty simple. All right. Now, for the y, though, we're going to show some work. So we're going to set up a proportion. We're going to do y over root 2. Y is the real number, so that when I go over here, I have to do 5 over 1. All right. Or I could do 5 over y equals 1 over root 2. All right. There's a couple ways you can set it up. If you remember us talking about proportions when we started, we said there were 8 different correct ways you can set up a proportion, but there's 16 wrong ways. Right? I'm always going to do it as y over root 2. Okay, that's just kind of the way I'm used to doing things. So y over root 2 equals 5 over 1. Okay, go back and look at that again real quick. Y over root 2, 5 over 1. You notice the circled part was in the denominator both times. The actual length is in the numerator both times. This is what we get. So now we're going to cross multiply. 1 times y is just y. 5 times root 2, keep our equals in there. All right, 5 times root 2, the 2 is under the root, the 5 is not, so we cannot multiply them together and get 10. We just put 5 root 2 and put my label. Now, I know that some of you, I've seen you do this in your homework. When you cross multiply, you do y, you cross multiply, you get 5 root 2. You like to do this kind of thing, where you put in a fraction, you completely forget your equal sign. This is wrong. I'm going to mark it wrong. I marked it wrong back when we first started learning proportions. Don't do that. All right. So all I do is set up a proportion, cross multiply, solve. If the y is not by itself, we'll have a little extra work to do. We'll do an example of that here in a second. All right. So let's go look at another example. All right. So on this one, I have my 45-degree angle. I didn't tell you the sides were congruent on this one, but I told you it was 45. So we can do a little bit of quick math. 90 plus 45 is 135. 180 minus 135 is also 45 degrees. All right, so we now know that these two angles are equal, so therefore coming across here x and coming over here to y, those are equal as well. All right, now if I know one of them, then I automatically know the other one. So really all I have to do is show the work for one of them. I'm going to go ahead and show the work for x. So we're going to put our numbers in, 1, root 2. Okay, so we're going to set up our proportion. So I'm going to do x over 1 equals 8 over root 2. X over 1 equals 8 over root 2. Okay, now we can cross multiply this. All right, so x times root 2 equals 8. Now I have to get x by itself, so I'm going to divide by root 2. And these cancel out. So now I have 8 over root 2, but this is what we just talked about back in these types of things here. We cannot leave that root in the denominator. So we're going to do this multiplying process and over here. So let's take a look at how that works here. So I can't leave the root in the denominator, so I'm going to multiply by root 2 over root 2. 8 times root 2 is 8 root 2. Root 2 times root 2 is root 4, but we know the square root of 4 is 2. Now 8 and 2 can be reduced. They're both divisible by 2. So 8 root 2 is going to become 4 root 2. And 2 is going to become 1. We don't really need the 1, so we'll just say x equals 4 root 2 units. Now remember, x and y were equal. They were across from equal angles. So they have to be equal sides, so we can just automatically say y equals 4 root 2 units as well. Now, some of you may have noticed that when we started right here, and we did the cross multiplying and we divided, we were really right back to where we started. Okay, so let me show you a little shortcut that if you understand it, you can do. If you don't understand this and you start doing it in the wrong times, then you're going to get a whole lot of problems wrong. But let me show you a little shortcut you can do. So I'm going to come back here and I'm going to write this proportion again. X over 1 equals 8 over root 2. Okay, that's what we started with. When something is over 1, just like it was over here in our answer, we don't have to write the over 1. So when I have this x over 1 equals 8 over root 2, I can literally just scribble out the 1. And I have x equals 8 over root 2. You'll notice that when we cross multiplied right here and then divided, that took us to x equals 8 over root 2. Same thing we have right here. All right, so if you have something over 1, you can just scribble it out. Scribble out the over 1 part. You don't really need it. Now, here's my answer. X equals this. But we can't leave it like this. It's the same thing we did over here. So we would do the multiplying by root 2 over root 2. We would get 8 root 2 over 2, and we would reduce it to 4 root 2. We don't need the over 1. All right, so you'll notice how the work there at the end is the same. If you understand this, when it's over 1, you can just scribble it out. Go ahead and do that. Saves you a little bit of time, a little bit of steps. If you don't understand it, then just keep cross multiplying, keep solving, all right, and hopefully you'll kind of catch on a little while with this over 1 thing. Excuse me. That's also the reason I always put x over 1, y over 1. I don't do 1 over y and 1 over x, because if you have 1 over something, you can't scribble the 1 out. Like if I have 1 over 3, I just can't scribble the 1 out and say, hey, that equals 3. No, 1/3 doesn't equal 3. Okay, but 3 over 1 does equal just 3. So that's why I always put that the 1 or the root 2 or the root 3 or whatever in the denominator. Okay, all right, so let's take a look at a 30, 60, 90 triangle now. All right, so we got a couple possibilities here. I got 3 different ones. So right here, I gave you the number on the hypotenuse. Over here, I gave you the number across from the 30. And then on this final one, I gave you the number, that's a 30, so that must be a 60. So I gave you the number across from the 60. So they all work a little bit different. So let's take a look at this one first. Now, if you remember 30, 60, 90 triangles, always in the side ratio of 1, root 3, and 2, and we always say it in that order. So 30 is up here, 90 plus 60 is 150, 180 minus 150 is 30. Across from the 30 is our 1. Across from the 60 is our root 3. And then across from the 90 is our 2. 1, root 3, and 2. So now, let me cover this up for a second. We're not going to do that one yet. We're going to solve for y. Y over 1 equals 6 over 2. Y over 1 equals 6 over 2. Cross multiply, 2y equals 6. Divide by that 2, y equals 3 units. Alright. Some of you may have said, hey, Mr. Oates, isn't this one of those things where we can just scribble? Yep, you can just scribble out the 1. Alright, scribble out the 1, reduce the 6 over 2, you get 3. Okay, same thing, you can do that. Alright, now let's look at the next one, x. So we have x over root 3 equals, I'm not really going to use this, I'm going to stick with this because I know the 6 is definitely correct. I'm pretty sure the 3 is right. That wasn't too difficult to work, but just in case I got it wrong, if I try to use this number to solve for x, x will automatically be wrong as well. So I'm going to stick with the 6 and the 2 because I know they're definitely right because those pieces of information were given to me. All right, so x over root 3 equals 6 over 2. Now, you can't scribble out a 1 here. All right, so we're going to cross multiply. 2x equals 6 root 3. And then I'm just going to divide by the 2 and divide by the 2. We're going to reduce the 6 and the 2 though. 6 divided by 2 is 3. 2 divided by 2 is 1. So this equals 3 root 3 over 1. I don't really need the over 1 part. So x equals 3 root 3 units. Alright. Let's take a look at another example. Remember, anytime that you need to pause the video, alright, because I do move pretty quickly after I show you the example, and you may not have time to write it down. So pause the video, write it down, take good notes. Remember, you're going to be taking quizzes on these things, so having good notes is going to be helpful. Alright, here we go, another 30, 60, 90 triangle. Now this one's not drawn the same way. You'll notice here the 60 was down at the bottom right. Here the 30 is down at the bottom right. Now I could flip it so it's something like this. It doesn't matter which way the triangle is turned, because what matters is that you have the numbers 1, root 3, and 2 memorized. So across from the 30 is the 1. Across from the 60 is the root 3. And across from the 90 is the 2. Alright, so we're going to set this up. Let's go ahead and do x. X over root 3 equals 5 over 1. Alright, so x over root 3 equals 5 over 1. Now, can you just scribble this one out? I guess you could, but we usually only do that when it's under the variable, the x or the y or the z or whatever, what letter we're looking for. So we're just going to cross multiply here. X times 1, that's pretty easy, it's just x. 5 times root 3, that's really easy, it's just 5 root 3. Remember, the 5 is not under the root, the 3 is, so we cannot multiply them together and get a 15. We just put the 5 outside, keep the 3 inside, put our label on it of units. Remember, our labels could be inches or feet or centimeters, yards, miles, all different kinds of things. Just we're going to put units if they haven't been given one to start with. Alright, so we just solved for x. We're going to solve for y now. So y over 2 equals 5 over 1. I'm not going to use this 5 root 3 and put it over root 3 and all that. Number one, if I got it wrong, it'll automatically make this wrong. And actually, that's kind of difficult. So we'll go y over 2 equals 5 over 1. So we'll set that one up now. Y over 2 equals 5 over 1. This is a pretty easy problem. Cross multiply. 1 times y is just y. 5 times 2 is 10. And label units. Alright. So we did one where the number was on the hypotenuse. We did one where the number was across from the 30. Now we're going to take a look at one where the number is across from the 60. This one will be a little bit more difficult. Okay, so 30 60, and 90. All right, across from 30 is always the 1. Across from 60 is the root 3. And across from 90 is the 2. All right, I'm going to go ahead and start with x. So x over 1 equals 9 over root 3. X over 1 equals 9 over root 3. All right, cross multiply. X times root 3 equals 9. I'm going to divide by root 3. These cancel out. I'm going to divide by root 3. We cannot leave that root in the denominator, so we multiply by root 3 top and bottom. I get 9 root 3 in the numerator. Root 3 times root 3 is root 9, and the square root of 9 is 3. Now I'm going to look to reduce. I can reduce this number outside with this number down here. Cannot reduce that because it's under the root. 9 and 3 are both divisible by 3, so x equals 3 root 3 over 1. We don't really need the over 1 part, so 3 root 3 units. Now, once again, some of you may have noticed, hey, it's over 1. I could just scribble it out. I have 9 over root 3. Gets you right here. You just start from there. Basically, you ignore this little cross multiplying and dividing step. All right? So, let's go to the y now. Y over 2 equals 9 over root 3. Y over 2 equals 9 over root 3. So, let's cross multiply. 2 times 9 is 18. Y times root 3 is y root 3. We divide by root 3. These cancel. We divide by root 3. I cannot leave that root in the denominator, so I multiply by root 3 on the top and the bottom. I get 18 root 3 over 3. 18 and 3 are both divisible by 3. So 18 divided by 3 is 6. I still have that root 3. 3 divided by 3 is 1. I don't really need that, so y equals 6 root 3 units. All right. Now, I will tell you that your book teaches us a little bit different. All right. Sometimes, and I've seen different books do it different ways, but sometimes your book will do something like this. They'll say, for that 45, 45, 90 triangle, let me bring that back to you. If you know a leg, okay, like on this one, we knew a leg, then all you have to do is multiply that leg by root 2 to get the hypotenuse. Well, yeah, that's what we did. We multiplied the leg by root 2, and it gave us our y value. Okay, but over on this one, when they give you the hypotenuse, you have to divide by root 2 to get back to the leg. All right, well, that's what we did. We took 8 divided by root 2 to get back to x, and x and y were the same, so we didn't really show any work for the y. I'm not a huge fan of that because it's a lot of memorizing. Well, if they give you the leg, then you multiply by root 2. But if they give you the hypotenuse, then you have to divide by the root 2. And on a 30, 60, 90 triangle, it gets even a little more complicated than that. Now that works. All right, it does work. There's nothing wrong with it necessarily, but we've done a lot of work with proportions, so I want you to do the proportions, okay? I do want you to do the proportions, all right? On this one, if they give you the hypotenuse, then you have to divide by 2 to get the short leg, and then you have to take the short leg times root 3 to get the long leg. So you have to memorize that. Right? If they give me the hypotenuse, then I divide by 2 to get the short leg. And then once I know the short leg, I can multiply it by root 3 to get the long leg. Okay, over here. Well, they gave me the short leg, so, well, same thing. I multiply by root 3 to get the long leg, but I multiply by 2 to get the hypotenuse. All right? If you set up the proportions, it works the same way. I multiply right here to get the long leg, and I multiply right here to get the hypotenuse. And then over here, if they give me the long leg, I have to divide by root 3 to get to the short leg, and then I have to double that to get up to the hypotenuse. So there's just a lot of different memorizing that you'd have to do. You know, if they give me this, then I do that. But if they give me this one, then I got to do it a slightly different way. And if they give me this one, I got to do it a different way. And I've seen way too many kids get confused. If you will just memorize for a 30, 60, 90 triangle, 1, root 3, 2, and put them in order and set up your ratios, your proportions, and cross multiply and solve, you will be fine. Okay? On the 45, 45, 90 triangle, right, just memorize 1, root 2. Okay, that's all you have to do. Memorize those numbers, put them in the correct order, cross multiply and solve. Okay? Alright, I want you to pause the video and do this one. Okay, pause the video and do this example. When you're done with it, come back. I'm going to show the work, and then we're going to do a 30, 60, 90 triangle, and we're going to be done. Alright, so go ahead, pause the video, do this one real quick, then come back and watch to see if you did it right. Alright, you should have that done already. If you don't, serious, pause the video, do the work. Alright, here we go. 90 plus 45 is 135. 180 minus 135 is 45. So this is a 45-degree angle down here. That means equal angles, sides across from them, x, and across from here, y, they have to be congruent. So as long as I solve for one of them, I know both of them. I know that 45, 45, 90 triangles have 1, 1, and root 2 for their ratios. So we are going to set up a proportion. You can do it for x or y. I'm just going to do it for y. I did it for x last time, so just to be fair, you know, keep things even, we'll do y this time instead. So y over 1 equals 7 over root 2. Alright, for those of you who noticed, yes, it's over 1. We can scribble it out and just start here. For those of you who don't quite get that yet, I'm going to go ahead and do the cross multiplying just in case. So y times root 2 equals 7. Divide by the root 2. You'll notice it takes us right back to where we were, 7 over root 2. So either way, we're going to have 7 over root 2, but we can't leave the root in the denominator. So we multiply by root 2 over root 2. We get 7 root 2 over root 2 times root 2 is root 4, and root 4 is 2. Now we look to see if we can reduce 7 and 2. Nope, not divisible by the same thing. You cannot reduce this to, it is under a root. This one's not under root. You can't reduce those. So we're just going to leave it just like that. Y equals 7 root 2 over 2 units. And x equals the same thing. X equals 7 root 2 over 2 units. Remember, why does x equal the same thing? Because we had two equal angles, so we have to have two equal sides. In this case, it's going to be the legs. A leg can never equal a hypotenuse. All right, last example. Copy it down, pause the video, do the work, come back and check it. So I'll give you however many minutes you need to do that, but seriously, pause the video, do the work, come back and check it here in a minute or so. All right, so you should have done this. If you haven't done it, I'm going to keep saying it, pause the video, do the work. Don't come and just watch this until you've actually tried it, because you need to try these on your own before you come to class. Because when you come to class, if you've never tried any of those, you're not going to know what to do when I actually give you one of those quizzes. Right? So here we go. 30, 60, 90 triangle. How do I know it's 30? 90 plus 60 is 150. 180 minus 150 is 30. We know that for a 30, 60, 90 triangle, it is 1. 1 goes across from 30. Root 3 goes across from 60. And 2 goes across from 90. So let's solve for y first. Y over 1 equals 15 over 2. Okay, you can see that right there. Y over 1 equals 15 over 2. Hey, look, it's over 1. I'm going to scribble it out. So there's my answer. Y equals 15 over 2 units. That was pretty easy. If you didn't see that, this is what your work would look like. Cross multiply, get 2y equals 15. Divide both sides by 2, and you get 15 over 2. Can't reduce it. You don't need to go to decimals. All right, let's do x. X over root 3 equals 15 over 2. X over root 3 equals 15 over 2. There's nothing here that I can scribble out, so I do need to cross multiply. 2x equals 15 root 3. Divide by 2, divide by 2. Those cancel. Check for reducing with 15 and the 2. There's nothing to do there, so x equals 15 root 3 over 2 units. There we go. You need to be able to do these types of things when you come in, because we will have a quiz over that, a short quiz. Alright, so 1, 1 root 2 for 45, 45, 90, and 1 root 3, 2 for 30, 60, 90. That's the end of lesson 7.4. We're getting close to being done with chapter 7. There's a couple lessons left, but they all kind of go together. Alright, so 7.5 and 7.6 and 7.7 are all trigonometry lessons. We'll be hitting those shortly.